what is the collection framework which is available in the Java library. Simply, a collection groups together the elements and allows them to be retrieved later. Simply, it is used to group a number of objects together as a single unit, and is it visible to everyone? Any one of you? Okay. Okay. Then a collection is simply it is allowed to group a set of elements as a single unit, and it allows to retrieve whenever if you want to retrieve those elements, right? And the collection in Java is a framework, as we have discussed in the last class, that provides an architecture to store and manipulate the group of objects. So simply this framework consisting of a set of classes and as well as interfaces through which, because all these mechanisms are, all these classes or interfaces which are available in the collection of Java is try to how to make the set of elements as a group and how we can access those elements. All these are dealing with that particular concept. Only the thing is the way which they are operating, the way which they add or they remove or they search, the process is only the difference among, that exists among the all these different classes and as well as the interfaces, right? As you all know that, you know, interface consisting of interface methods, there is no code at all, only they provides the signature itself. It is the responsibility of the classes, those who implements that particular interface, right? And similarly, a class consisting of a set of data numbers as well as member functions. So these all member functions are meant for manipulating or dealing with the data which is present in the class, as you all aware of it, right? Now let us see how what are the various classes and interfaces that are available in the Java library, and then we'll see one by one what is the functionality of it. So in the last class we have discussed this particular diagram, that it shows the whatever the number of classes and interfaces that are available in the Java library is depicted in the form of figure. Here you can observe that a collection is an interface. It consisting of different interfaces like list, queue, and set. Again, the green color represents the classes. These are the classes which implements these interfaces. So array list is a class which implements the list interface. Similarly, the linked list is also a class which implements the list interface, like vector, stacks. Similarly, queue is also another interface, the priority queues and array queues. These are all some of the other classes which implements the queue itself, queue interface itself. So, and as we have observed, somebody drawing right. So these are the some of the methods which are available in the collection. These are all methods are supported by all the collections in the sense. So these are the interfaces which are available, which implement. These are all collections. List is a collection, queue is a collection, set is a collection. These all things are meant for grouping a set of objects together as a single unit, and there we can perform certain operations on it. Certain operations in the sense you can retrieve, you can add, you can delete, you can search. So these are all things, right? So these are all the methods which are supported by all the collections. Because while discussing in detail with each and every one, once again we'll look at it. So now, as I told you, collection groups together elements and allows them to be retrieved later. You can observe. So here, this is the representation of a list of books. So here you can imagine that all of them are similar, but they should be different with they should be differ with the serial numbers. Like this is the first book, this is the second one, this is the third one, like that. Right? You can imagine in such a way a list of books. So this is the way where we can organize a list of books. Similarly, it is a set of books. List of books in the sense they are all ordered in nature. Okay. Similarly, the set of this diagram depicts the set of books, and this represents the stack of books. So in the stack of books, you cannot place the elements wherever you want. Always you are supposed to be inserted the last. That isn't it or not? Last in first order, right? So the set is an unordered collection of unique elements. The set is a collection of unordered a list of unique elements. A list is a collection of remembers the order of its elements. A list is a collection that remembers the order of its elements. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like whatever the order it have. So that the list remembers those elements, right? Like stack. So as you are aware of that, stack remembers the order of its element, but it does not allow you to insert elements in every position. You can add and remove the elements only at the top, right? So these are the some these diagrams will give you some information, fundamental information regarding what exactly a list, what is a set of book, what is a set, and what is a stack, right? And similarly, the queue, it adds. Okay, we'll see later. Now, iterator interface. So, iterator interface provides the facility of iterating the elements in a forward direction only. In a forward direction only. Right? These are the methods which is supported by iterator interface. So, the first one is the public boolean has next. So, iterator in the sense which is used to do some operation in a forward direction. So, has next. It returns true if the iterator has more elements, otherwise it returns false. Iterator in the sense, so it is supposed to revisit the n number of elements in future, so then it returns the true value. Otherwise, that is the last element or that is the last position in the list, so it returns the false value because it indicates that no more element to be traversed next. And public object next, it returns the element and moves the cursor pointer to the next element. That means when we want to move from one position to another position, as we discussed in the linked list, how we are moving temp from one place to another place. In such a way, the object next, the method next is used to move the cursor from one position to another one, right? And the cursor points to the next element. So remove method is used for deleting an element. Removes the last elements returned by the iterator. It is used less used, right? Iterable interface. So the iterable interface is the root interface for all the collection classes, because for all these collection means a group of grouping a set of objects, right? So when we are performing operations on it, we require the help of iterator. So that's why it will act as a root for the whole collection classes. The whole collection classes, whatever we have discussed previously. Okay, so those all. It contains only one abstract method, the iterable interface. Interface means interface is also similar to the class, but it consists only abstract methods. Abstract methods in the sense there is no definition for it, only signature will be there. So here the method which contains the iterable interface is iterator T. So this is the iterator method. Okay, it returns iterator or the elements of type T. So it is a generic mechanism type T, as we have discussed in the first class, right? Generic classes allow us to pass types as a parameters, right? Now collection interface, because the next node of the iterator is collection. So the collection interface is the interface which is implemented by all the classes in the collection framework. What are the classes which are available in the collection framework? Yes, these are all array list, linked list, vector, stack, green color. You can observe the green color rectangle boxes represents the classes. So these all will implement the interface collection, because these are all array list, linked list, vector, stack. These all implements the list interface. In turn, it interfaces the, it implements the collection also, because that is the base for it. And now, so here some important points is it declares the methods that every collection will have. In other words, we can say that the collection interface builds the foundation on which the collection framework depends. So we will see very soon what exactly it is. Right? Some of the methods of the collection interface are Boolean. Boolean means true or false values. Right? Object Boolean add all to the collection C. So these all methods very soon we will discuss in an example where we can add a set of elements using the methods of the linked list class which are available in the Java framework. Right? So this is a list interface, because the linked list falls under the list interface. List interface is the child interface of collection interface. List interface is the child interface of collection interface. It inhibits a list type data structure in which we can store the ordered collection of objects. It can have duplicate values also. List interface is implemented by the classes array list, linked list, vectors, and stack. Okay, so this is the fundamental code how to instantiate the list interface. List followed by the data type, list one, and as you are aware of that, how to create a new list in Java, right? So similarly, for creation of instance for the list interface using linked list, using vectors, using stacks. So these are the various methods in list interface that can be used to insert, delete, and access the elements from the list. Because if you want to create a linked list, right? So you can create a list with this type, and whatever the methods that are available in the linked list class, okay, you can apply all those things to the interface of list. Okay, so we will see an example how, because as we have discussed in the previous classes about linked list. Now let us see how we will add elements into the linked list using the linked list class of the collection. How it is going to implements the collection interface. So let us see a simple example program where we can add. So this is the code for adding elements to the linked list. Adding elements to the linked list. Previously, we have created our own linked list using Java, and where there we can add elements at the specified position. Now, what we are going to see is, now you can add the elements using the methods which are available in the linked list class, which implements the collection interface. That is the difference. Now you can see. So this is the linked list. L1 is equals to new linked list of string, because here I want to add some names. So that is the reason I'll make the data type as a string, right? So system.out.20 initial list of elements. Now you can observe L1 dot add Ravi. That means the first node will be created, because here you need not define the structure how to create a node and all, because by default all of them are defined in the linked list class of the Java library. So that is the reason you need not define the node structure and all. Directly you can use the method which is available in the linked list class add for adding a new element, because initially we are creating a new list right now. So that is the reason Ravi will act as a first node. And then actually after adding the first node, if you want to add a new node to the previous list, what you are supposed to do? So head dot next is equals to current node. So what happens in that case? Whatever the previous first node which you have created, so the next part of that node should be linked with the newly entered node, so that a link will be established between first node and the second node. So after that, if you want to add new node to that, that means third node, if you want to add to the list, what you are supposed to do? Second node dot next, you are supposed to link with the third node. So in such a way, we are supposed to perform. But here, we don't. You need not write that much of code for adding elements into that. Simply, you can write that a method add, so that internally the add method itself, it was defined in such a way, right? So directly you can use that method and then you can add elements. In that way, I will add 3 elements. One is Ravi, Vijay, and Ajay. So now let me check whether the list is created or not. For that purpose, system.out.println, after invoking add e comma e method is now, because here e comma e specifies 1 minute. I'll show you the method. So that you will have some idea, right? So these are the methods. First we will look at the methods and then we'll discuss the program. Boolean add e comma e. It is used to append the specified element to the end of the list. It is used to append the specified element to the end of the list. And another one is what? Int index comma e element. It is used to insert the specified element at the specified position index in the list. So in the insertion program previously, which we have discussed, wherever we want to insert the element, we wrote the code for it, right? That means first we need to verify the position if it is 0, so that we will add at first. If the position is last, we'll add at the last. If it is in between the head and tail, based on the position, we will try to add it. So that is the way which we wrote the code in the previous example. Now there is an inbuilt function add into index. That means you can specify the index and followed by you can specify the name of, a data item which you want to insert or node which you want to add. So directly what happens? Directly the node will be added at the position specified by you. And add all. It is used to append all the elements in the specified collection to the end of this list. Whatever the previous list you have, now you have collection. Collection means a group of elements are present in it. So those group of elements will be, say for example, it is another list. You have list 1 which we have already created. Now we want to add a list 2 to the list 1. Directly we can add in such a way specified collection to the end of this list in the order that they are returned. Now is it visible to everyone? Any one of you? Is it visible and audible? Okay, done. Right. So that is about add all. So here another format is, it is used to append all the all of the elements in the specified collection to the end of this list in the order that they are returned by the specified collections iterator. Both of them are same actually. By mistake, it was inserted 2 times. Right? Now, void add first. So this is directly, which if you want to add at the beginning of the list, you can add by using this particular method. It is used to insert a given element at beginning of the list and add last. You can add the element at last directly. In the previous classes, while we were discussing about the insertion, someone may came up with an idea like, instead of traversing the list from the beginning to the end, when we want to insert an element at the last position, okay, if we maintain another name for the last node as a tail, and so that it saves the time while adding the element at last position. Okay, so here you need not worry about all these things, performance issues, because directly this method will allow you to add the element at a last position. Right? Hope you understood. Quite clear. It is used to remove all the elements from the list. And cloning. So it is used to return a shallow copy of an array list. So similar copy will be created with that. And contains in the sense, if you want to search for an element, whether it is present in the list or not, okay, so this particular one will be used, this particular method is used for finding whether the element is present in it or not. It returns the Boolean value as an output. That means if the element is present in it, it returns true value, otherwise it returns the false value. All right. Similarly, so many methods are available in the linked list class. So I'll share this document with you. You please go through it, because all these operations, get first, get last, these are all the methods meant for searching the elements or retrieving the elements from the list itself. All right. So I'll share this document with you. You please go through it, and if you have any queries, let me know in the next class. Right. So let us go to the execution of the program which we have started. Right. So here the add 1 comma Gaurav. So here I am specifying the index. That means here the element will be added at the specified position based on the index specified by you. Here the index is 1. Right. So now I'll try to print the elements after this particular one. Right. After adding this particular element. Now I'll create another linked list L2. Okay, L2 dot add. Here I was added 2 elements to the second linked list. Now here L1 is a one linked list and L2 is another linked list. L1 contains 4 elements up to now. Ajay, Ravi, Vijay, Ajay, and Gaurav, because Gaurav is the another element which we have added. So these are the 4 elements which are present in the list L1. Now I would like to add L2, which consisting of 2. So it is a collection. L2 is again, it is a collection which consisting of 2 objects. So for that, L1 dot add all of L2. So what happens is, after executing the statement, all the elements which are present in the L2 will be appended at the list L1. Right? Otherwise, what we have to do, we need to add L1 dot add of Sono, L1 dot add of Anwan. Suppose here the case only 2 elements you have. So that is the reason you can write. You may not observe the difference between these two, but when you can imagine that in the real-time scenario, there are thousands or lakhs of objects will be present in the different lists. So writing the code for adding all these elements by using this simple statement is a difficulty task, and even performance issue. Complexity gets increased. So that is the reason, with the help of this particular method, we can add a list at the end of the another list. Right? So after adding the second list, we'll try to print the list 1, L1. Now here I have created another list, L3. So by using that, I'll try to I will try to add 2 more elements to the L3, and I'll add L3 to L1. In the similar way, what way we can add L2 to L1 to linked list linked list 2 to linked list 1. In the similar way, linked list 3 will be added to the linked list 1. Right? And after that, again, this is the way how you can add new node to the existing list at the specified position. Okay? All right. Now, so this is another way of adding element at the first position, because as we have seen the list of methods which are available in the linked list collection, linked list class. Okay, add first. So this is the method meant for adding new node at the beginning of the list itself. Like add last. So Harsh is going to be add at the end. So now what we did with this program, initially we have created a linked list without writing any code for adding elements. Simply we'll call the method add, which is available in the linked list class, which implements the collection interface. So the add method directly adds the element to the linked list. Okay, so that is point number 1. In such a way, we will create 3 nodes, and after that, we'll add a new node at the specified position by using another format of the. Here you can observe that polymorphism, compiled polymorphism, right? The parameters are different. So the one by specifying the position, we will try to add the new element to the existing list. Like that, we have created list 1. After that, we have created another list L2, and that list will be added to the list 1 by using the method list1 dot add all of list 2. So this add all method will add all the collection or all the list elements to the first one. First one in the sense, whatever the list you have specified, L1 dot add all of I2. So L2. So list 2 will be added to the L1. Suppose if you write L2 dot add all of L3, linked list 3. What happens in that case? The elements which are present in the linked list 3 will be added to the linked list 2. So like that you can write, depends upon your requirement, you can use it. So the add all method, what we observe is add all method will add all the elements in the one list will be added to the another list. Right? So in such a way we have. So now you can observe after invoking the add e method, first when we are creating first linked list L1, we have created with 3 nodes, Ravi, Vijay and Ajay. After that we will try to add a new element with the help of index. So in that case we have added Gaurav at the position 1. So in the list we will try to add the element at the position 1. So previously we have considered the list index starts with 0. So always we'll try to add position -1. So if it is the case, what happens? We are supposed to add the Gaurav at 0th position because we have specified the position as 1. So 1 minus 1, 0. Actually, we are supposed to add at the beginning of the list, but the method add here they were defined as whatever the position that you have specified, directly it was placed in that without writing position -1. Right? So that is the reason why it was placed in the second position. And that means in the list it is first. 0, 1. Right. Now, and similarly, we have created another list, second list with the name Sonu and Hanumat. So those will be added, Sonu and Hanumat. Here you can remember that when you are adding the second list to the first list, whatever the order that they are present in the second list, in the same way they were added. Suppose in that case, Sonu, Hanumat are the order of the elements which we have added. First we have added Sonu and second we have added Hanumat. So in the same order, they were placed in the list 1, right? And after that, we have added another element to the list 1 add all, and after that we have created another list, linked list 3. Okay, so totally we have added 3 in it.